Students, today we are going to discuss about closed loop sampled data control system problems. We have gone through the theory sections of closed loop data control system. And now we have the question. Find C of Z by R of Z for the following closed loop sampled data control systems. Assume all the samples to be of impulse type. And here first question is shown in the figure. You have to find the value of C of Z by R of Z. Similarly, in the second question also you have to find the value of C of Z by R of Z. So first let us go to the solution of this closed loop system. And here you can see that R of t is the input, C of t is the output, and the gains are G1 of S, G2 of S, and feedback path has gain H of S. And here the switches are shown as delta t of t. That means here you are taking the sample of E of t here, so that you will get E dash of t here. So a sampler, this represents an impulse type sampler. This is also another sampler. So this will give you, whenever E of t is given to this, samples will be obtained at the output. Okay. So let us take the first diagram. This is the first diagram, and here you have to, if this inputs are not marked, you have to mark first the different signal values at the output of adder or subtractor, or at the output of each gain block. So here it is marked as E of t, which is error signal, that is R of t minus B of t, and E dash of t is the output of this sampler. And at the output of G1 of S, let us represent it as a D of t, and at the output of this sampler, the output will be D dash of t, and final output is C of t. You have to find the ratio of C of t with the R of t by taking the set transform. Okay. So let us first take this block. Okay. First of all, we have to write the equation for C of Z, so that we are taking this section first. So here you can see that the input block G2 of S is an impulse sampled signal. See here, the sampled signal is given as D dash of t. So at the output of C of t, you can represent this as G2 of S. Input is D dash of t and output is C of t. And since there is a sampler is applied at the input of this block can be represented as the set transform block as G2 of Z. Then the input will be D of Z and output will be C of Z. In terms of set transform, we can represent like this. Okay. So this can be represented equivalently by the equivalent block diagram like this. So here you can write C of Z will be equal to D of Z multiplied by G2 of Z. So G2 of Z into D of Z will be C of Z. See, whenever a sampler is given at the input, then you can directly write the set transform of this G2 of S. Okay. So what is C of Z? C of Z is the set transform of C of S. G2 of Z is the set transform of G2 of S. D of Z is the set transform of D dash of S. Okay, here input is D dash of t. So here D of Z will be the set transform of D dash of S. How will you get the S function from the time domain function? C of S will be obtained from the time domain function as Laplace transform of C of t. Similarly, D dash of S is obtained by the Laplace transform of D dash of t. So these are the equations. You have to number the first equation, that is C of Z, because you have to find the ratio C of Z by R of Z. Okay. So next you can go to the next block, that is the input block, that is G1. This block you can find the input is E dash of t and output is D of t. So you can represent that block like this. Okay, G1 of S is here, E dash of t is here, D of t here. In terms of set domain equivalent block, you will get E of Z, and this will be G1 of Z, and the output will be D of Z. What is E of Z? E of Z is obtained by the set transform of E dash of t, right? So you can write E of Z will be equal to set transform of E dash of S. Similarly, D of Z is the set transform of D of S. Okay, so you can write the equation as here you will get the equation as D of Z will be equal to E of Z into G1 of Z. That is written here. That is D of Z will be equal to G1 of Z into E of Z. So from the equations from the previous equation, that is here, that is E of z will be equal to G2 of z into D of z. From that equation you can substitute for this what is this equation. That equation can be substituted in this equation, that is D of z equal to G1 of z into E of z. So you will get a C of z. See, this equation can be substituted into this equation, that is C of z will be equal to G2 of z into, instead of D of z you can write this equation, D of z will be equal to G1 of z into E of z. So you will get C of z equal to G2 of z into G1 of z into E of z. Okay, that is equation, that is this equation is substituted in this equation. Okay, so here you can directly write G1 of z, G1 of z is the Z transform of G1 of S, E of z is the Z transform of E dash of S, and E dash of S is the Laplace transform of E dash of t. So next we are going to, now you have these two sections. You have independently considered this section and this section. Now you have to consider the feedback section. So in the feedback section, how it comes is, you have to take this path, that is from this sampler to this path. Okay, so the input to the cascaded block G2 of S and H of S is an impulse sampled signal as shown in the figure, that is D dash of t, G2 of S and H of S, B of t is the output. And see here you can write this has a D of Z, this is Z transform will be D of Z is input, and since there is a sampler behind this G2 of S, you can write directly as a Z transform of G2 of S into H of S. Okay, and that output will be equal to B of Z. See here in the previous case, here you are directly writing G1 of Z because you are considering only this block, and now if you are considering this block, you have to consider from this portion to this. Okay, and here whenever sampler is applied to the cascaded combination of G2 of S and H of S, then the Z transform can be written as a Z transform of a cascaded combination of G2 of S and H of S. So here you can write the equation as B of Z equal to D of Z into Z transform of G2 of S into H of S. That is written here. And here you can see D of Z is here. D of Z you have find out from the equation this one from the previous block. So you can substitute this value of D of Z into this equation. So you will get B of Z equal to Z transform of G2 of S into H of S. Instead of D of Z you are substituting G1 of Z into E of Z. So G1 of Z into E of Z is written here. So now you have this equation here from the figure. See here, what is at the summing point output is E of t. What is E of t? E of t is R of t minus B of t. So you can write at the summing point you will get the equation as E of t equal to R of t minus B of t. You have to number the equations before proceeding. You have to number each equations because these equations will be used later. Okay. So here, since you know that E dash of t is equal, because it is a sampled version, so you can write it as E of kt. So that is the impulse sampled signal, and so by superposition principle, whenever E of t is equal to E dash of kt, E of kt, then instead of t you can substitute kt. So you will get E of kt equal to R of kt minus B of kt. So here E of kt, R of kt and B of kt are impulse sampled signals of E of t, R of t and B of t. When you are taking Z transform of this one, you will get E of Z is equal to R of Z minus B of Z. Now you have the equation for R of Z and B of Z separately. And also you can substitute. What you want to find out is you have to find out the ratio of C of Z by R of Z. Here you can see R of Z is here. So you have to isolate this R of Z here. So R of Z will be equal to E of Z plus B of Z. So instead of B of Z you can substitute from, see here B of Z you have derived this equation. Okay. So instead of B of Z you can substitute this value. So you will get the R of Z is equal to E of Z plus Z transform G2 of S plus H of Z. This is B of Z. What is B of Z? See, B of Z is this one. Okay. So R of Z will be equal to E of Z plus, instead of B of Z you are substituting this value. This is the value, that is Z transform G2 of S into H of S into G1 of S into E of Z. So you are substituting that value, and here you can see that this can be written as, see, this can be written as E of z is common, so you can take E of z outside. So E of z is taken outside. The rest of the terms are 1 plus z transform of g2 of s into h of s into g1 of z into E of z. Now you have the equation for C of z and R of z, so you can easily find the ratio C of z by R of z. So C of z by R of z is given by, C of z is what is C of z? C of z is this one, okay? G2 of z into G1 of z into E of z. So you are writing that term, and at the denominator you can write this term. So at the numerator and denominator E of z is common, so you can cancel it out. So the net equation for C of z by R of z equal to G1 of z into G2 of z divided by 1 plus z transform of G2 of s into h of s into G1 of s. So that will be equal to this can be written as a set transform of this is g1 of z, g2 of z divided by, here this can be written as 1 plus g2 into h of z into g1 of z. That is represented because we are taking the set transform of cascaded combination, so you can write it as g into h of z. So this is equation for c of z by r of z. So next you can do the second problem. Here there is a zero order hold, and you can represent it. See, what is the second question? Second question is this one, and here is a zero order hold block, so you can replace it with g0 of s, and the value of g0 of s is equal to 1 minus e raised to minus st divided by s. So the zero order hold in the system is replaced by G0 of s as shown in the figure, and where G0 of s is equal to 1 minus e raised to minus st by s. So this is the block diagram. Instead of Z0 of h, you are substituting this, and you can proceed in the same manner as you have done the first problem. And here you have to first write the equation for C of z. So you are first taking this this block, and you can see that here the sampler is not applied just before g of z. So here the sampler is applied here, so you have to consider this. To write the equation of C of z, you have to consider this cascaded block. So the input to this cascaded combination is E dash of t, and output is C of t. So in the set domain equivalent circuit, E of z is there and C of z is there, and what is the value of this cascaded combination? That is set transform of G0 of s into G of s. So you can write the equation for C of z as a z transform G0 of s into G of s into E of z. That is the thing, and here each and every term is given. C of z is equal to z transform of C of s, E of z is z transform of E dash of s, and Z of s is Laplace transform of C of t, and E dash of s is Laplace transform of E dash of t. Now you have the equation for this one. Next block is this one, that is feedback path. You can see that their sampler is provided at the input of this h of s. So you can write it as the input is C dash of t and output is B of t. Here the input is written as C dash of t. Why it is written as C dash of t? You can see in the diagram that here the C of t is coming here, but its sampled version is taken at the output of this sampler. So here C dash of t will appear. So you can write C of z, h of s and B of z, that is the Z domain equivalent circuit, and here B of z will be equal to h of z into C of z, and you can you know that Z of z is Laplace transform of C dash of s. C dash of s is equal to Laplace transform of C dash of t. Okay. So here from the figure you can also find what is E of t. E of t is equal to R of t minus B of t. So you can write it as and instead of t you can substitute kt. So E of kt equal to R of kt minus B of kt. So the set when we are taking set transform, you will get E of z equal to R of z minus B of z. And here instead of B of z, we can substitute this value, that is what is B of z, h of z into C of z. You have to find out the ratio of C of z by R of z, and here now you have E of z is equal to R of z minus h of z into C of z equations. So now you have this equation, and you have also another equation, E of z equation. What is E of z equation? See, here C of z is equal to this one. Okay, sorry. Okay, C of z is equal to this equation, so you can substitute for C of z. So this is E of z is equal to R of z minus, instead of B of z you are substituting this one. Instead of C of z you can substitute this value. See, C of Z is this value. So you can substitute this value in that equation. So you will get this equation. This is simply rearranging the equation. So you will be getting C of Z is equal to Z transform G0 of S into G of S into R of Z minus H of Z into Z of Z. Okay. See, here what we are doing is, here now we have this equation and we have also this equation. Sorry, here we are not substituting C of Z. We have this equation and we are substituting E of Z value in that equation. So E of Z, now we have this equation. So we are substituting this value in this equation, not C of Z in that equation. Okay. So you can write Z of Z will be equal to Z transform of G0 of S into G of S into R of Z minus H of Z into C of S. So here you can simply multiply the terms inside the bracket and you can rearrange the equations. So finally you will get a C of Z by R of Z ratio like this. So C of Z by R of Z is equal to this equation, and this can be written as G0 into G of Z, and this can be written as G0 into G of Z into H of Z. So this is the equations, and I am not explaining the complete steps because these all are simple rearrangements. You can go through the problem once again and you will get this result. So your requirement is you want to find out C of Z by R of Z. The method for doing the problem is the same. Kindly go through the problem once again and prepare notes. Thank you.